Hello everyone, I'm a tutor with Uplatz and today we are going to learn about SQL training. We have already covered basics of SQL and databases. So overview for today's lecture is going to be SQL commands, SQL constraints, and a little bit of basic MySQL hands-on. So to start with SQL commands, we have a data definition language. We have data manipulation language, data control language, data query language, and finally transaction control language. What is data definition language is that where you are defining your data or you're defining your database schema. That's where all the DDL commands are introduced. As in the examples for DDL commands would be create, drop, alter, truncate, comment, and rename. The syntactical part we will cover later in the course. But for now, whenever we are trying to describe the definition, we are trying to modify or create the structure of our database or the objects that are present in the database, like table, index, function, views, stored procedures. All those commands are part of DDL, that is data definition language. Moving to next, we have data manipulation language. What happens in data manipulation language is that whenever we are trying to insert, update, or basically we are trying to modify our data, that is nothing but data manipulation language. When we insert a new row, we know that now the data has changed. Now the values of the data is not the same anymore. So that's where the manipulation comes into the picture. Next we have is data control language. What happens in a data control language is that it includes commands such as grant, revoke. It mainly deals with the rights, permissions, as in if for the perfect example for this would be a new employee joining an institution will be given or will be granted an access for privileges to databases. When any employee is leaving an organization, we need to revoke all his user rights. That's where we use the revoke command. These are data control language where we are controlling the access to the databases. Next we have is data query language. It is somewhat similar to DML, but we are not manipulating anything here. We are just selecting something. So we have select command in DQL. Next in line we have TCL, that is transaction control language, where it is dealing with the transactions within the database. There are 4 different examples we would encounter in the later part of the course for TCL commands. We have commit, rollback, save point, and set transactions. Commit is that whenever a transaction is successful, the database commits itself, saying that this is the final state. And rollback, what is rollback? Whenever there is a system failure, in that case, all the transactions are rolled back to its original state. In case of save point, let's say we have 10 transactions to be executed. I create a save point at the 5th transaction. So whenever my 5th transaction gets completed, that will be my new commit. Next is set transaction. This is basically specifying the characteristics of the transaction that you have planned to execute on your database. Now, the most important thing is that we have so many rules and regulations we need to follow when we are trying to access a particular database. We need to check for constraints. There are various forms of constraints. Constraints are basically rules for the data in that table. So what is happening here is that they are used to limit the type of data that can go into a table. Let's say there is one particular organization for which we are maintaining a database. There, the employee name cannot be null. So I define a following constraints such as not null. So whenever there is a new entry, the name has to be specified unless and until the database won't accept that entry. So there are few constraints which are commonly used in SQL. We will discuss them one by one. We have not null, unique, primary key, foreign key, check, default, index. So to start with not null, what is a not null is that just the example that I gave you. What happens in not null is whenever we are trying to create a column, it will never accept null values. So let's say if you are in a bank organization where you are trying to enter a new data for a new user, but that user does not have a mobile number. Then in that case, our database, if it has a not null constraint, then our database will not accept that entry as the mobile value is not specified. For that, we need to give some mobile number so that the entry is accepted into our database. We will see this example by executing it in our database. I'll give you a small demonstration. on how exactly does this work. So let me take you to the black screen. So this is where your MySQL commands you are going to execute. Once you have downloaded, you can open MySQL command line client, where you have to enter the password that you used while initializing your setup. And once entering the MySQL, you will see that there are two databases that are already provided while downloading. Those were Sakila and World. Apart from that, I have my own, right? So I have created a, another new database with the name Jaya. And what is happening here is that we are going to create new tables. We are going to create views, procedures, function in a new database schema. Let's say I create a database, Uplatz. So now when I go and show my databases, I can see that my Uplatz has been added to database list. Now, what we'll do is we'll try to demonstrate not null in our table. First, before that, we have to define a table. So we'll create a table in our case. Let's say users. So Uplatz dot users, and then we will define our columns. Let's say ID. I keep it as an integer value, and I add my not null constraint to it. Then we have another column that is name, which is a varchar column. Limit I'm setting to max. And I also keep this as a not null constraint. Finally, we have age, which is integer, and we have not kept any constraint on this column. Okay, there is some error. What did I do? Name varchar. So there was a spelling mistake. Varchar. Now it is here. So when I describe Uplatz dot users, you will see that the three columns that I had defined are created. ID, which was an integer type, and it had a not null constraint. So we have null value as no. That means null values are not accepted in this column. We have created name, which is a varchar column. In that also we have kept not null constraint. That means there is a possibility that no null values can be inserted into it. And lastly, we have age column, which is an integer value, and we did not specify anything. So by default, it marks null value to be yes. That means it accepts yes. It accepts null values. So we'll try to insert some data into our table. Values. Let me push some values into it. 1 comma, let's say name ABC, and then some age, let's say 30. Oh, the database has to be selected. Users, enter. So when I select all the columns from my table Uplatz.users, I will see that whatever I just inserted has been entered into our table. So now let me again try to insert some null values. Now we have defined ID to be an integer value, which is not null. Let me try to insert some null values into it. It throws an error saying that column ID cannot be null because I have set the value, I've set the constraint, and I have to follow that constraint. This is where the constraints are most useful for. Now let's say I have this table Uplatz.users. Now I want to change the definition of this table. I want to add not null constraint for age as well. What I will simply do is I'll alter this table Uplatz.users, and I will modify my existing column, which is an integer, and add a new constraint to it. So when I now describe, you can see that the null condition, which was yes initially, that means it was accepting age to be null initially, is not being accepted anymore. It has been changed. So now if I try to insert null values into my database, into my table, it will not accept, saying that column age cannot be null. So that's how constraints can be put to use, wherein you are trying to set some rules so that your data is not changed, your data is not altered. Next we have in line is unique constraint. It ensures that all the values in a column are different. Both the unique and primary key constraints provide a guarantee for uniqueness for a column or set of columns. A primary key constraint automatically has a unique constraint. Both are very much similar, but there is just one difference between a primary key and a unique key. A unique key can have one null value. A primary key cannot have null values. So you can see that you can have many unique constraints per table. That is true, but only one primary key constraint per table. So now this is one example that I have written for you. We are creating a table persons with ID to be integer, and it is a not null constraint. Last name and first name. First name has no constraint on it, nor does age has. And now we have created a unique key on ID. So what happens is that when you're trying to insert some data into it, it will accept null values, but it will not accept repetitive values. Let's say I have already inserted one record with ID equal to 1. It will not again allow me to insert the same record because there is already a unique key present in the table, which is 1 for that particular row. Next we have in line is primary key. What happens here is that the primary key constraint uniquely identifies each record in a table. So basically, primary key is the most important topic when we are talking about indexes. Primary key helps us identify each row uniquely. Primary key must contain unique values and it cannot contain null values. But in case of unique key, we can have one null value, one null row, because that is also considered to be unique. A table can have only one primary key, and in the table, this primary key can consist of single or multiple column fields. So basically what it is trying to say is that there can be only one primary key. Now that one primary key can consist of one particular column or a combination of two columns. Let's try to demonstrate this example and show it to you in database. How does this work? Going back to the terminal. So we have our terminal here. We'll try to create the same table. Let's say uplatz.persons, and we will create our own ID to be integer, not null constraint. Then we have the last name as varchar 255. I have defined with a not null constraint. Next we have first name. Again, that is varchar. We have age with no not null conditions, with no constraint at all. And now we will go ahead and define the primary key for this table. We decide that our primary key would be ID. Close it. And your table is created. So when I try to describe this table, as you can see, my primary key is against the ID column. I have 4 columns as the way I have defined. For ID and last name, it is a not null constraint, so I have no against them. While for first name and age, there were no constraints, so we have nothing against them. Now, we'll try to insert one row into it with some value. Persons, values, let's say I insert 1, then some random ABC, and some last name XYZ, and let's say age 30. It got inserted successfully. Select star from the table. So when we try to do this, you can see that the row that we inserted is already present in that table. Now again, let us try to insert something else. Let's say 650. Let's change this to some random number. Let's change this as well. Now this is a new row that we are trying to insert. But what we have done is we have kept the primary key to be the same. Let us check what happens once we try to execute this. Duplicate entry 1 for key persons.primary, which means that ID 1 was already present in the table. And since ID is a primary key, there cannot be a duplicate entry for this table with the same ID number. So this is how we can explain primary key. Going back to our keys, types of keys. Next we have is, there are some rules for defining primary key. As you must have seen in the demonstration, the two rows can't have the same primary key value. It is must for every row to have a primary key value. The primary key field cannot be null. The value in a, so when you try to insert a null value into the primary key ID, it will throw an error saying that null values are not accepted. The not null constraint is by default applied on that particular column when you are using it as a primary key. The value in a primary key column can never be modified or updated if any foreign key refers to that primary key. So this is the most important rule. What is happening that you have created a table, persons, wherein your ID was the primary key. Now you are referring to that column from some other table. So if you update that primary key here, it is mandatory that you change those foreign key relationships in your another table as well. Otherwise, it might throw an error saying that relationship not found. Next we have is foreign key. A foreign key, as I already told you, is a key that is used to link two tables together. A foreign key is a field or a collection of fields in one table that refers to the primary key in another table. So what is happening here is that we have created one table. As you can see here, I've created a dummy table for you, orders, in which order ID is not null, order number again with a not null constraint, and there is person ID, which is an integer value. Now here we are defining order ID to be the primary key, and we have kept person ID as the foreign key, which is referring to this person's table we created, and it is referring to the person ID column of that table. So basically person ID from orders table is reflecting to person ID from persons table. That is the relation between orders table and persons table. So in that case, we can say that the person ID becomes the foreign key for orders table, but it is a primary key for persons table. Similarly, we can say that order ID is the primary key of this table. It would be foreign key for some other table. Moving to next, we have n number of keys, one of which is a super key. Now, a super key is a group of single or multiple keys which identifies a row uniquely in a table. A super key may have additional attributes that are not needed for unique identification. So just going through this example, we have this SSN number, we have some employee number associated with it, and let's say we have the employee name. Now in this example, employee SSN and employee name are super keys. But it would be still okay that only employee SSN is enough for me to identify a unique record. So that is what is a super key. A super key is basically a superset of all the keys, wherein you will have one or more keys grouped together to identify each row uniquely, of which two or more attributes might not be of uniqueness. So here in this case, as you see, the num and name column are not showing as much importance as SSN alone can identify that unique row. Moving to next, we have is alternate keys. In alternate keys, it is a column or group of columns in a table that uniquely identifies every row in that table. A table can have multiple choices for a primary key, but only one can be set as the primary key. All the keys which are not primary key are called an alternate key. So there are various methods to identify or to uniquely identify a particular row. But as we have a constraint that primary key can be only one for any given table, in that case, all the remaining ones become the alternate key. So if you see in this example, we have student ID, roll number, and email. They're qualified to become a primary key as they uniquely identify a row. But since student ID is the primary key, as student ID alone is enough to identify a single row, we can say that roll number and email, they become the alternate keys. So in those cases where I don't want to use student ID for uniquely identifying a row, I will use roll number and email, which will help me identify that one particular record. Next we have is candidate key. Candidate key is the set of attributes that uniquely identifies a tuple in a identify tuples in a table. Now candidate key is a super key with no repeated attributes. The primary key should be selected from the candidate keys. So basically candidate key is like a superset for primary key. One of the least general key will be selected from candidate key, and that will become your primary key. Just going through this example to make it easy to understand, we can say that in this table, student ID, roll number, and email, all these are actually candidate keys. But out of this, student ID alone is capable enough to become the primary key. So here roll number and email will become alternate keys, and student ID, roll number, and email together will go into the candidate key. What are the properties? It must contain unique values. Candidate keys may have multiple attributes, just the way we have in our example. We have 3 attributes: student ID, roll number, and email as a single candidate key. It must not contain. So whenever we are talking about any keys, it should not contain null values until unless it is a unique key, wherein only one null value constraint is allowed. It should contain minimum fields to ensure uniqueness. Uniquely identifies each record in the table. That's the main purpose of the keys. So to reiterate whatever we studied till now, this is a table wherein my candidate key will be student ID, roll number, and email together. Out of the candidate key, I will select one candidate to become my primary key, which is student ID, as it is alone able to identify the individual record. And the remaining ones go under the alternate key. Now next we have in line is the compound key, where it has 2 or more attributes that allows you to uniquely recognize a specific record. It is possible that each column may not be unique by itself within the database. That this can also happen when, let's say you have a table like this. It would be better explained with an example. In this case, order number and product ID can't be a primary key, as it uniquely does not qualify a record. There is a possibility that in same order there are multiple products, so order number would be repeated. So there cannot be, the primary key cannot be order number. In case of product ID, there is a possibility that same product is being ordered in different orders. So here also product ID can be repeated multiple times in this table. So here both cannot become the primary key of that table. But what we have here is that it can become the compound key. That is, 2 capable columns or attributes which are uniquely able to identify will become my compound key. So here 2 potential primary keys can become my primary key together, compound, which is called as compound key. So here order number and product ID together forms a compound key. Next is we have composite key. Composite key is the combination of 2 or more columns that uniquely identify rows in a table. The combination of columns guarantees uniqueness through, though individually uniqueness is not guaranteed. Hence they are combined uniquely to identify records in a table. The main difference between compound and the composite key is that any part of the compound key can be a foreign key, but the composite key may or may not be part of the foreign key, which is very true. That in case of previous example, here order number and product ID, this can be part of any other table and it can become the foreign key for that table. But that may not be the case in your composite key. Composite key has multiple attributes just the way we have it here in compound key, but it cannot be, it cannot work as a reference from another table. It cannot become the part of the foreign key. So that's composite key for you. And now we will move on to little MySQL hands-on to tell you what exactly we are going to deal with. To take you back to the MySQL terminal, here it is. So as I showed you, we have different databases created here. Apart from databases, we have different tables, and this is the most root level in our data in our system database, where exactly we start defining. Now world is one enterprise, Uplatz is one enterprise. So when we deep dive into this, I will try to show tables from those enterprise. So I will say show tables from, let's say, Sakila. So we have Sakila here. We have these many tables created in Sakila. We have 23 tables in the Sakila database. Now, if I want to check for one particular table, then I will describe that table. Describe Sakila dot actor. So we have it different columns here, where we have the field. We have 4 different columns in Sakila dot actor. Actor ID is given a small int data type. It is the primary key of this table. Now we have first name here. As I told you, that data type has to be very much optimal, and since there is a possibility that first name for Sakila is not beyond 45, so they have set the max value of a varchar to be 45. That means only 45 characters are allowed inside it. Same goes for last name. And coming to timestamp, last update is a column with a data type timestamp. When you don't insert any timestamp into it, you will see that the current timestamp will be visible or will be inserted into that table, as it does not accept not null value. So there has to be some default values given. So when we try to select is, we'll try to first, as you can see, there are so many records. So we had to abort our query in between. So for this, we have some ways to do. We will select limited numbers from the table. So select star from my database name dot table name limit 10. It will only retrieve 10 rows for me. And as you can see, the actor ID is the primary key. It will never be repeated. And how we can find out that the primary key is never being repeated? We can find out the count of table. So let's say select count 1. It will give me the count of table. And let's say count distinct actor ID from the table Sakila.actor. If both these numbers are same, that means the primary key was never repeated. As you can see, both the numbers are same, 200. So our primary key is never repeated. It has followed the constraint. Now count 1 is one form of aggregation, wherein we are trying to find out how many rows are present in that table. And in terms of distinct, we are trying to find out how many distinct actors are present in that table. So this is how you will be using your table. Next, let's say I want to retrieve data only for one actor. Let's say I want to retrieve data only for Christian. So now I will show you that why a primary key is very important, which is an integer. Select star from our table Sakila.actor, where I say that first name is Christian. I don't know how the spelling is being inserted into it, but let's say I give it in small letters, first name equal to Christian. So you can see that so many records are being shown for me, but I am specifically interested on Gabble, on that record where my last name is Gabble. So how do I do that? I need to add another condition as last name equal to Gabble. Now I am getting one record. But instead of adding two conditions, I can directly use a primary key, which is ID in my case, and I can retrieve that record. So it helps us identify a record uniquely, and that is where we are going to use the primary key. Moving to next, we have let's say, unfold a different table. So we will again try to show tables from Sakila. You may explore more if you want. We have film actor. So describe Sakila dot film actor. We have 3 columns in it. And now let's say I am describing actor. So describe Sakila dot actor. As you can see that if I want to see that which of the actors have acted in a film, so there has to be some relation between these two tables, and as I can see there is a relation on actor ID. I can retrieve those records, those actors from Sakila.actor table by joining it with the film underscore actor table to identify that which actors are actually the film actors. So this is the relation between these two tables. And actor ID is the primary key here. While in this Sakila.film actor, you can see that there are actor ID and film ID together are a primary key. That means we can call it to be a composite key. Actor ID and film ID together are creating one primary key. So that was basic MySQL for you, wherein if you want to record, you have select. When you want to insert some record into the table, you have insert command. Let's say I want to delete this record from my Sakila.actor. So I have this record. Okay, let's say I'll choose the last record, or probably we can try this on the newly created, just so that if we need this in the future, we can have it handy from Uplatz.users. So we had this entry here. Let's say I want to delete the user whose ID is 1. So there is a simple command for it, delete command, delete from Uplatz.users, where ID equal to 1. So now when I again try to select, I won't get any rows because now the row has been deleted. But the structure of the table is still present. Structure is still present with whatever constraints we had defined. Just that we have manipulated the data and we have deleted the record. So that was about MySQL. In the later class, in the later part of the course, we will learn more about the SQL queries. We will learn more about the joins we have in our table. We'll get into a little bit of complexities with respect to SQL. This was basic SQL for you. We covered DQL. We created our own database Uplatz, and we tried to insert rows into it. We learned about the constraints and various keys. Generally in various organizational organizations, uh, only primary key and foreign key does the work. The remaining keys are generally not preferred to be used. And in big data, there is no concept for keys because as I had already mentioned that in case of big data, it is an analytical database. So we need not require any keys there. That's all for today. Thank you. Hope to see you in the next lecture. Thank you so much.